Okay, we are doing Pythagorean Theorem. So just a reminder, Pythagorean Theorem only works when it's a right angle. Yes?
Yeah.
Okay, so here's a right angle, A, B, and C. A and B are just legs, they're the two sides, and C is your hypotenuse. Your hypotenuse is the longest side, it's across from the right angle. Yes? This is the side that's important, because if you mislabel the hypotenuse, then you're gonna get the wrong answer. Okay, so knowing that, let's look at number 1. So number 1 and 2, it just says, are the following right angles? So all we're doing is plugging these numbers in and making sure. Y'all put them away. Okay, so knowing that, I know that this is my C, and A and B don't matter. So I can label this one A or B, and this one A or B. So you just pick one. So I know that the formula is A squared, so 12 squared, plus B squared, which is 9 squared, equals C squared, which is 15 squared. And knowing that, I'm just going to type in my calculator. 12 squared plus 9 squared equals 225. And then if I do 15 squared, it also equals 225. So, is this a right angle? Yes. Yeah. That was any kind of triangle, but yeah. Or I think it was obtuse, acute, and right. Okay, so looking at number 2, same concept. The only difference is, one of your side lengths is a radical, which is fine. When we square it, what's going to happen? Yeah, it cancels. Which side is C?
9.
11. It's across from the perfect angle, or what we're thinking is the perfect angle. These two are obviously not right angles. Does that make sense? Okay, so I know that we have 9 squared plus the square root of 115. Now, if it's not a whole number and it's not positive, please put it in parentheses. Equals 11 squared. And then technically here, doesn't your square root cancel your squared if you're doing this by hand?
Mm-hmm.
Yeah, however, in our calculator, it will do it for us. So we have 9 squared plus the square root of 115 squared, and that equals 196. And what's 11 squared? Good Lord, I don't know what I wrote. 121. Are those equal?
No.
No. Any questions there?
Mm-mm.
Pretty simple. Okay, that's pretty much as hard as it gets. I think 3 and 4 really aren't that much harder. And that's really as far as it goes. So this is an easy day. So here you'll notice you're missing a side length. So all that means is you have to find it. We know the formula, we know the other two, therefore we can solve for it. So if this is B, then this is A, because this is across from my right angle, so that's my C. So I know I have 4 squared plus B squared equals 10 squared. Now technically I could do 4 squared, 10 squared, and then subtract, but could I just subtract 4 squared?
Yeah, you could.
I don't have to simplify that. So I get 10 squared minus 4 squared, and that gives me 84. So I have B squared equals 84. Am I done? Is that my answer?
No.
What do I still need to do to get B by itself?
Get rid of the square.
How do I get rid of the square?
Square the other side.
Square root.
Square root.
The opposite of squaring is a square root. Now, is 84 a perfect square? No. So this didn't give me decimals, so I'm not going to have you type the square root of 84. We're going to actually break it down to a simplified radical. So 2 goes into 84 42 times. 2 goes into 42 21 times. 2 does not go into 21. What goes into 21?
7.
3 and 7. So what matches?
2 and 2.
So I get to take a 2 out, and what goes back in the house?
3.
And
7.
what's 3 times 7?
40. 21.
21. And then we label it M. Any questions there? Okay, so let's look at number 4. Ooh, why can't I stop yawning? Okay, look here. What am I missing?
You're missing C.
I'm missing C because this is a cross, so this is my C value. So it doesn't matter which one's A and which one's B. So I have 7 squared plus, again, is this just a whole number?
No.
No, so we have to put it in parentheses. Now, one thing I do want you to understand is what happens. So 8 square root 3. When you square this, this is power to a power because 8 is technically being multiplied to 3, the square root of 3, right? So you have to square the 8, which gives you 64. And then when you square the square root of 3, what happens? Doesn't the square root cancel the square root? We just have 3. So then 64 times 3 is 192. So what I would just need you to understand that that's how you simplify that if you have to do it by hand. Yes? Or it has letters or whatever. So knowing that, I can still just type in my calculator for now. 7 squared plus parentheses 8 square root of 3. Oop. And that equals 241. Now what?
Square root.
Square root cancels the squared. And then 241, we need to break it down. However, if I start listing all my prime numbers and dividing it out, none of them are working. Oop, I didn't type that one right. Goodness, what am I doing? Okay, none of my prime numbers go into it, so what does that mean? That's your answer, yeah. So we have C equals the square root of 241. Don't forget to label feet. Now, one thing I do want you to realize is technically, when we take the square root of both sides, don't we get a positive and a negative when we take the square root of a number?
Yeah.
But we're talking about sides of a triangle. Can you have a negative side length?
No.
So that's why we're ignoring that plus and minus. Does that make sense? Okay. We're actually not going to do number 6 because it gets repetitive. But look at number 5. So the only difference here is it just didn't give you a picture. It's just telling you. Well, if you really, really like a picture, triangles are really simple to draw. I know, three lines. It's difficult. So C is 15, A is 11. We don't know B. So we know 11 squared plus B squared equals 15 squared. What do I do?
Subtract 11 squared.
Subtract 11 squared. And I get B squared equals 15 squared minus 11 squared. And that gives me 104. Now what?
Square root.
Square root both sides. Square root cancels the squared on the left, and I'm left with B equals, well, let's break down our 104. 2 goes into that 52 times. 2 goes into that 26 times. Yes. 2 goes into that 13 times, and 13's prime, so we're done. What do I get to take out?
2 and 2.
No,
Oh,
just 2. This one doesn't have a pair.
Okay.
So we get to take out a 2, and what goes back in the house? 2 and 13, so 26. Which, pretty simple. Okay, last one's a word problem, but it literally labels 2 of the sides, so do you really even have to read it that carefully?
No.
No, it says Craig and Daniel Cantwell, I don't know, want to determine the distance x across a pond on their property. So this is what they want to determine, x. They are able to measure the distance shown, so they are able to measure diagonally, apparently, at 65 feet, and how wide the pond is. Oh, it says find how wide the pond is, and round it to the nearest tenth, because when I'm talking in real life situations, do we want a radical or do we want a decimal?
You want a radical. Decimal.
A decimal, thank you, okay? So we're going to actually type it in the calculator and get a decimal. It says to round it to the nearest tenth place. So knowing that, we have which one's my C value? 65. So I know I can say x squared plus 40 squared equals 65 squared. So I'm going to subtract my 40 squared from both sides. And I get 65 squared minus 40 squared gives me 2625. Now, part of the reason it's nice if you don't simplify these first is these are going to give you really big numbers. It's just easier to type these numbers. However, it doesn't matter either way. How do I get rid of my squared?
Square root.
So this time I'm actually going to type the square root of 2625. And I get x equals 51.2 feet. So that's it. Simple.